So the mass spectrometer could be one of the easiest, analytical techniques that you study, but it's not that easy if we do a full interpretation and if you find one of these mini exam questions. So the heaviest peak is the molecular ion. Molecular ion tells you, very important, the MR of your compound, which is like what you will see is the mass spectrometry to be used the most, okay? And for example, in combination with NMR, you can find, the MR of a molecule. Sometimes you will find the molecular formula because you're also given the elemental composition to get the empirical formula. However, we have so many other peaks. One tricky question that you could get is, why do you have one peak, very small, very, very small, with a very low relative intensity, so relative abundance, at 1 plus of your molecular ion? In fact, this specifically at 87, we can call it the M+1 molecular ion. True reason. Actually, no, one reason only, because the relative intensity is so small. Okay, the only reason why you have an M+1 is because of the carbon-13 isotope. Okay, because you only have a very low relative abundance, and as we know, carbon-13 is very low in relative abundance. So this is a very tricky question because we might not think about it directly. Also because different ionization methods. One is electron bombardment, which is when there uses little bullets that kick off other electrons to give you the ion. But you also have the electrospray ionization. The electrospray ionization, it would give you a molecular ion that actually has, and we can write it like this, an MH with a positive charge, because the electrospray ionization adds a proton. Okay, so it does have a mass. But it would be stated in the question specifically that it's an electron spray ionization, or maybe you would get a hint like it must be like a large organic molecule. So, wait, I don't use the bombardment because you get so many fragments. But it would be stated. So if it's not, and there is electron bombardment, and that the ions are just caused by these the removal of electrons, then the very low intensity peak, 1 plus of your fragment or your molecular ion, it must be because of carbon-13. Then other tricky part, the fragments. Okay, you could get, of course, a lot of fragments depending on the molecule. One thing that is useful to think about, so let's say that we have a molecule like this, the lines are the hydrogens. If you identify a fragment, you identify basically where the bond of this molecule has broken. So automatically you will be able to identify 2 different fragments. So it's useful to think it this way, because with one thought, you have identified 2 peaks. Okay, that's the other thing. And this is very useful when you have to distinguish different molecules that have a very small difference. For example, a branched alkane and a linear alkane. They could have slightly different fragments. And here, to work it out, it's very important to write the displayed formula and then work it out, just literally looking at the part of the molecules that could be different. Useful also for example, aldehydes and ketones. They would have a very small different fragments. So that's the second useful things about the mass spectrometry. Okay. The third very tricky one is, what if, so the molecular ion is at 86 mass to charge ratio. But as you can see, you have many other peaks. You have one at 43, pretty high. If that doesn't correspond to a fragment, it could correspond to the molecular ion, but with a 2 plus charge. I haven't seen really exam questions about this, but it's important to be aware because it's easy to forget what the mass to charge ratio is. So the mass is the mass of the element divided by the charge. Okay, the charge, of course, would be how many electrons have been removed. So if we have the molecular ion at 86, you may have the 2 plus ion at half of it. So those are the useful things. For your exams, the most important is the finding the MR, so the molecular ion, because then it can be used in combination with other techniques. But be aware of this like 1 mark question where you ask fragments or carbon-13 or even mass to charge ratio, like in the last example I mentioned. Okay.